everyone, myself Dr. Vinod. I'm working as Associate Professor in Laxman Reddy Institute of Technology and Management in the branch of Electrical and Electronics Engineering. So, today the subject name is Basic Electrical Engineering. Topic name is Kirchhoff's laws. So, let us go with that. So, first of all, let us go with the introduction. So, in the introduction, as we know that in electric circuits, basically we find two things. One is how the current flows and how the voltage is distributed across the different components. So, to determine how the current flows and how the voltage is distributed across the different components, definitely the Kirchhoff's laws are the fundamental tools in this circuit analysis. So, in this context, these laws are based on the principle of conservation of energy and conservation of charge in the electrical network. Once I am repeating, so two things are very much important in electrical network or circuit. One is how the current flows and how the voltage is distributed across the different components. For this, Kirchhoff's laws are very much important. So, the Kirchhoff's laws consists of two main rules. The Kirchhoff's law consists, as I told, two main rules, in which the first one is what? Kirchhoff's current law. So, this Kirchhoff's current law that relates completely with the current at a junction or node. Second one, we have the Kirchhoff's voltage law. Shortly we call it as a KVL. Kirchhoff's current law, shortly we call it as a KCL. So, this Kirchhoff's voltage law that relates completely with the voltage around the closed loop. So, together they are very much helpful for solving the complex electrical circuits by setting up equations to find out the unknown currents and voltages. So, the point to be concluded here is Kirchhoff's laws, they are helpful for solving the equations to find out the unknown currents and the unknown voltages. So, why Kirchhoff's laws are very much important? So, on the screen if you see, they work for both DC and AC circuits. As already we have discussed, to find out the unknown current and to find out the unknown voltage in the circuit, definitely these are helpful. As these are helpful, and it is not limited to only DC, but this also works in AC itself. AC and DC, both. So, they apply to solve simple as well as the complex circuits. So, whenever I say simple, it's like easily solvable. Complex means it is like very time taking to solve the problems. Maybe number of loops may be increased, maybe critical issues, maybe something where I can say like more number of loops comes into the play. There I say it's a complex circuit. So, they are the foundation for network theorems like superposition, Thevenin's and Norton's, because these laws are very much helpful for the foundation of the Thevenin's theorem, Norton's theorem and superposition theorem. So, as I told, they are the foundations. If you are unaware of Kirchhoff's current law and Kirchhoff's voltage law, foundations of Thevenin's theorem, Norton's theorem and superposition theorem will be critical to understand. So these are widely used in electrical and electronic engineering to calculate the unknown circuit parameters. So next, so we have given a table where it shows the law, that is two types of laws. We know that KCL, KVL. Shortly KCL is denoted as, and KVL is shortly denoted for Kirchhoff voltage law. So the based on the KCL straight away that deals with conservation of charge, KVL that deals with conservation of energy. So the meaning I can tell you, that is charge cannot accumulate at node. That's why the sum of entering currents must be equal to sum of leaving currents. Once I am repeating, KCL, the charge cannot accumulate at a node. So that's why the sum of currents entering must be equal to sum of currents leaving. Similarly, if you go for KVL, that is dealing with conservation of energy, here the net energy change around a loop is 0. So sum of the voltages in a loop must be equal to 0. Next, so let us go with the Kirchhoff current law statement. The Kirchhoff current law states that the algebraic sum of all currents entering and leaving node or junction in electric circuit is 0. So simply it is given like the total current entering a node is equal to total current leaving. It's already discussed in the previous slide. Entering current must be equal to the leaving current. So KCL states that the total currents that are entering a node is equal to total currents that are leaving the node. Short to understand simply. Next, the concept behind the law. So definitely for any law there must be a basis. So the KCL is based on the law of conservation of electrical charge. Already we have seen in the previous table. That is a fundamental concept behind this law. Since charge cannot accumulate at node, so what happens? The amount of charge, the flow into the node per unit must be equal to charge of amount that must flowing out. So in is must be equal to out. So charge in must be equal to charge out. So this is one of the diagram shown on the screen, that is for Kirchhoff current law. If you see in the above diagram, the currents are denoted here is from A, B, C, D, E, F. So the currents are moving here and there in the circuit, where starts from A, ends with F. A, B, C, D, E, F. That is here A, B, C, D, E, F. So here it is shown like A plus B plus C plus D equal to E plus F. So how we have written this? This is a fundamental question. See here, whatever the entering current, already we have discussed, the entering currents must be equal to leaving the currents. So from A to F, whatever the currents that are entering the node, we have to keep it on the LH side. And whatever the currents that are leaving the node, we have to keep it on the RHS side. So LHS side must be equal to RHS side. So that is leaving the current must be equal to the entering the leaving current to the node must be equal to the entering current to the node. So if you see here, A entering, B entering, C entering, D is also entering. So that's why we kept entering is A plus B plus C plus D on the LH left hand side. So leaving the node, the currents that are leaving the node is E and F. Those we kept on the right hand side. So the conclusion can be done on this is the Kirchhoff current law says like entering the node, currents entering the node must be equal to current leaving the node. Okay, so according to the case here, entering currents are A, B, C, D and leaving currents are E and F with a negative value. So the equation can be written as A plus B plus C plus D equal to E plus F. LHS is equal to RHS. As these are leaving, there in the statement it is shown like a negative value. So A plus B plus C plus D minus E minus F equal to 0. If I move it on the right side, the equation stands A plus B plus C plus D plus equal to E plus F as shown in the screen. Next, generally in electrical circuit, the term node refers to junction or connection. That is like a multiple components or elements or currents carrying like components and cables. This I am talking about electrical circuit. In closed circuit, a current flows in any or in or out lane must exist. This law is to analyze the parallel circuit. This is I am talking about general circuit. This I am talking about the closed circuit. Next, we are going with Kirchhoff voltage law. So Kirchhoff voltage law purely deals with the voltage. So KVL shortly, full name is Kirchhoff voltage law, and this also we call it the second law. The first law is the Kirchhoff current law. The second law is Kirchhoff voltage law. This states that the algebraic sum of the voltage in a closed circuit is equal to 0, or algebraic sum of the voltage at node is equal to 0 shortly. So once I am repeating, this states that algebraic sum of voltage in a closed circuit is equal to 0. Or shortly we go with sum of voltage at node is equal to 0. So if you see here A, B, C, D, E and F. Totally we see the sources here, that is voltages A, B, C, D, E, F. So second law says like, that is Kirchhoff voltage says A plus B plus C plus D plus E plus F is equal to 0. Sum of the voltages in a closed loop must be equal to 0. So that's why what are the voltages we have here, that is A, B, C, D, E, F. If I add all those, that has to be equal to 0. That's why they have mentioned here A plus B plus C plus D plus E plus F is equal to 0. This law deals with voltage as we know. A voltage source is connected with 5 passive components, that is B, C, D, E, F. Okay, here if you see, this is a voltage source, B, C, D, E, F are the passive, having different voltages across them. But if you see arithmetically, the voltage difference between them add together because these components are connected in series. But according to the KVL law, the voltage across the passive component circuits is always equal and opposite to the voltage source. So this point is very much important. As they are connected in series arithmetically, but according to the KVL, the important context is what? Voltage across the passive component in a circuit is always equal and opposite to voltage source. Hence, the sum of the voltage differences across all the elements in a circuit is always 0. So whatever we see, we have seen there A, B, C, D, E, F. This is a source. They are the passive. So source plus passive is equal to 0. This is for today's class. Thank you.